Welcome to VINDAL'S Academy, and today I have a very beautiful question for you, and this is physics. Remember to hit the subscribe button, like this video and subscribe, and also make use of our other social media platforms, and I'm going to bet you this is going to be very wonderful. Stick with me to the end. The question says, a system of frictionless pulleys carries two weights hung by inextensible cords as shown. They say find I, the acceleration of the weight. This is the first weight and this is the second weight. Tension in the cord. This is the cord and these are the tension. The tension is the force that acts through the weight or through the cord. And then they said the velocity and displacement of weight, one of this weight, after 5 seconds from start, if the system is released from rest. All right, I want us to understand that whenever you have this kind of question, this is not an Atwood machine, rather a system of pulleys. In this case, we have this first pulley and the second pulley. Now, since this weight, W2, is supported by this rope or cord and this cord, therefore, the two of them are going to combine to support this weight. I mean, remember in a force diagram, or yes, in a force diagram, if you have a weight like this, and whenever there is a weight for a body, whenever there is a weight, let's say W, then there must be a force, a reactional force. That force may be a reaction. It can also be called a tensional force. So for that reason, this must be balanced by the other force for it to be in equilibrium. And for that reason, I am going to apply that principle here. I'm going to start with this weight 1, and then I'll do that to weight 2. But remember that the acceleration for this one, because the weight is bigger, it will have more acceleration. But because of the system, the arrangement of this pulley, when this one has gone one unit, this one is going to go half of the unit, because this, the more the force, the more the acceleration. The less the weight, the less the acceleration. So that is how this pulley is designed. So what I'm going to do first is apply the principle in this one. After applying the principle here, I will apply the principle here and then find the acceleration. See how I start. What I'm going to do is to say that what I'm going to have is this first one. Remember, and the body is moving down because of this arrow. This weight is moving down. And for this body to move this down and accelerate downward, it's going to have, the weight must be bigger than this tensional force. So I'm going to say that 80 minus T is equal to. So whenever two forces are subtracting each other, we are going to have a net force. So because it is a net force, I'm going to have MA. And this is my equation 1. All right. Now, when I come to the second one, because only one weight being supported by two ropes, I'm going to add the 2. T plus T is going to be 2T. And since this body is moving down, that means this must move upward. For this to move down, this must go upward. And that is going to be 2T. Remember, the two of them are holding it, pulling it upward. 2 of them minus this weight, minus 50, is going to be equal to, this one, M, is going to be 8. Why do I say 8? Because the weight is 80. The mass is going to be 8. That means divide 80 by 10, you are going to have 8, which is this. Because whenever you divide weight by 10, you are going to have mass. The 10 I'm talking about is acceleration due to gravity, and that is what I'm using here. And now, in this case, this is also going to be, remember, this is going to be 5. Mass is going to be 5. Why do I use 5? Because the weight is 50. If I divide this 50 by 9.8 or 10, I'm going to have approximately 5. Good. Or 5. Then this is going to be 5 times A over 2. Why am I putting A over 2? Because the acceleration with which it is going is half of the acceleration of the body of 80 Newton. So I have two equations. In this case, I am going to solve for. So I'm going to solve for the acceleration. So what I'm going to do is to, let me make t the subject formula and equate them. So I'm going to have that t is going to be equal to 80 minus 8a. I'm making t the subject formula here. Then let me make t the subject formula in this case. I'm going to have t is going to be equal to, this is going to this side and be adding. I'm going to have 5a over 2 plus 50. Remember that there is 2 at the back. I'm going to divide everything by 2. It's the same thing as multiplying by 1 over 2. And this is going to be, t is going to be equal to 5a over 4 plus 25. Now that I have t 80 minus 8a, and I also have t equal to 5a over 4 plus 25, and they are the same t, I'm going to equate them. So I'm going to have 80 minus 8a, which is going to be equal to 5a over 4 plus 25. Now I'm going to clear the fraction. Since the LCM is 4, I'm going to say 4 times 80. I'm going to have 320 minus 4 times 8a is going to be 32a, and this is going to be 4 times itself is going to be 5a plus 100. All right, at this point, I'm going to have that, I'm going to, collect like terms. This is going to be 320 minus 100, which is equal to 37a. And this is going to be 220 is equal to 37a. And a is going to be 220 divided by 37, which is going to be equal to 5 points. And that is going to be around 5.9 meters per second square. So this is the acceleration for this system. Now the next question is find the tension. The tensional force in this case is still this. So I'm going to substitute 5.8 in this equation. So what I'm going to do is to say that T is equal to, let me use, and this is going to be 80 minus 8 times, let me confirm, this is 220 divided by 37, 5.9 approximately, okay, times 8, and this is going to be 5.9. So T is going to be equal to 80 minus 47.7. T is going to be equal to, and this is going to be equal to 32.3 Newton. So that is going to be the tension at this point. The next thing is the velocity and displacement of weight 1 after 5 seconds from start if the system is released from rest. All right, this is the place it is. If I release this from rest, remember, okay, if I release it from rest, it's going this way. So I'm going to find velocity. I will use this. U is 0, and acceleration A is going to be equal to 5.9 meters per second squared. So I'm going to use V equal to U plus 80 after 5 seconds. Yes, I'm looking for the velocity after 5 seconds. So I'm going to have V from rest is 0. This is going to be 5.9 times 5. V is going to be 5.9 times 5. It's going to be 29.5 meters per second. All right, that is the formula for that, and the displacement. I'm going to use S equal to ut plus half 80 squared. U is 0. Remember, U is 0. And this is going to be 1 over 2 times acceleration is 5.9 times t is 25. T is 5 seconds. 5 squared is that. So I'm going to have 5.9 times 25 divided by 2. I'm going to have that distance is going to be 3.75 meters. Ladies and gentlemen, this is the solution for this question. Please don't forget to hit the subscribe button, support the channel as much as you can, and have a nice day.